Bring you back full screen.
Hey everyone, how's it going?
Good.
I'm Shah Selbe. I'm a National Geographic explorer and a fellow, and I work on how we can bring technology to help us with conservation, wildlife conservation and environmental protection. And so I have a lab where we build all those technologies, which you can kind of see part of it here. And so we have things like, over there you can see like 3D printers and laser cutters and all that sort of stuff, but we also have like kayaks and expedition things and all sorts of stuff that we use to build that. So I'm super excited to work with you all on this project over the next year or so.
We're starting to study microplastics and plastics. We're going to start working into the idea of seeing where plastic enters our Sacramento River Delta.
I build any kind of tech that helps us kind of figure out these kinds of conservation questions. So a lot of times it has to do with wildlife, but it's also like human impacts, like plastic waste, where it goes.
In terms of bottle floats, some of the students had some ideas of what we might build or what might be designed. Lily, do you want to share a little bit about your design that you had?
Sure. I had like a milk jug, and I put like 3 Ozobots in it to move it a little bit, and 3 GoPro cameras.
Oh, cool. Very cool.
Paula, do you want to share what you were thinking about your design for this?
So basically, it was a rover, and the rover would have trackers, cameras, and like kind of like headphones where you could hear things.
Oh, very cool. Yeah, that's great.
Miley, could you share a little bit about your design idea?
My idea was to put a tracker in the water bottle. The tracker would have a drone following it. The drone that had the camera facing down, showing where it was. When it got close to the ocean, the drone would notify us so we could go and get it before it gets into the ocean.
Yeah, that's a really good idea. I mean, the main thing for this project is we want to learn as much as we can about how things move through these systems, but we don't want to contribute to it, right? So we want to catch it before it goes and make sure that doesn't go in. And that's kind of like what we were talking about when this whole project came up, was how we can find ways where we can use, a bottle that we all have seen in the stores, we've drank fluids out of it before, how we can track something like that through that, because then it's very real. It's something that, everybody in your class, everyone that we know has like held on to one of these bottles, and we've thrown them away before. But usually once you throw them away, you don't really think about what happens to them and where they go. Let me show you one of the things that we work on here is this thing that we call Field Kit. And so Field Kit it's basically all those types of sensors that you guys are talking about, like the motion sensors, the GPS, all of those are sensors. And so what we created was our own circuit board that has those sensors on there. So let me show you. This is one of the Field Kit circuit boards right here. So this is basically, it's got a mini computer on there that allows it to track things. And we you can see right here, we have like a little SD card, which I think you guys have seen before for cameras and things like that. And it saves all that data to the SD card. And we have things on there like this white thing that you see right here is GPS, so that it knows where it's at, and it actually saves the GPS location as it's traveling around. This thing right here is Wi-Fi, so you can actually connect to this with your phones, and you can download the data and see where it's going. And then we have these radios on it. So this right here is a radio that actually sends its location to us, so we know where it's at in real time. And so we use these things out in the field. Right now, last week, we built 18 of these that went to Brazil, and they're being deployed in the Amazon in Brazil, in the rainforest. We're building another 30 or 40 of them that are going to go to different parts of the rainforest early next year in January. So that's like something that we use a lot here in the lab to tell us that same sort of data that you're talking about.
We want to find out how plastic trash moves into the river and through the river. What is your design process? What do you do to start with?
Yeah, so usually we kind of want to set it up so that we know what the design space is, so what we're trying to do. So as we had all those great ideas from all of you there, and I think Jim's probably talked to you about it, but like the idea here is we're going to try and use a regular bottle that we see in the stores. So if you want to use a regular bottle, there's 2 ways we could do it. One way we could do it is we could cut the bottle, we could put all the stuff inside of it, and then we could close it back and seal the bottle. And that way totally worked. the one thing we have to be careful about there is when we seal it, we have to be very careful to make sure that there's no leaks or gaps or things that are going to cause it to fill up with water and sink. Which, some of the stuff we've built has sunk before, and so we're very familiar with how to deal with that. But electronics doesn't like to be in the water. So if you put this type of electronics in something that sinks, it's dead. It doesn't work anymore. So we know that we want to use a bottle. The other way that we can do it is if we can take something like this and we can put it through the mouth of the bottle. And you see there's this is about an inch wide. And there's definitely bottles out there that have openings, the big mouth bottles. So I think things like Gatorade and some other stuff that you might have seen in stores that have these wider mouths. And with those, we could slide a camera or slide, these kinds of electronics inside, and we don't have to worry about the waterproofing part of it, right? We just close the top and we let it go. And so that might actually be an easier way because then you don't need the tools to waterproof them. So we know that that's kind of the idea around what we want to do. But I don't know what types of bottles are out there. I don't know what would work well in this kind of situation versus what wouldn't work. That's part of the research phase of the project. So I'd be very interested in maybe getting the help of all you to try and figure out what would be the right bottle to use there. So usually we try and map that out. So we'll have a big list on a whiteboard of all these different types of bottles that we can buy and bring it into the lab and then test, how does this fit in there? How can that come together? And that becomes a part of our early design process. Also, the other thing, too, is if we can measure them. Measuring it would be great. If you can measure the opening, if you can measure the length and the width of it, okay. Yeah, just, with a simple ruler and just jot those down, that'd be very helpful. I think right now we're very much in the research phase. Once we figured out what our design space is, so once we figure out which bottle we're going to use and we know how much room's inside of the bottle, how big the opening is, then that's going to help us figure out what type of cameras and all that stuff that we'll put in there.
And I'm assuming that the bottles need to be not only big, but they also need to be somewhat strong. What would be our ideal bottle?
Ideally, we want it to have enough volume on the inside that we could put stuff inside. So if you think about things like a circuit board that's this size or cameras and different stuff, we'd like the bottle to be big because the bigger it is, it gives us more room to work in. I think the mouth being as big as possible is another really important thing. And the last thing I want to say is the type of plastic that the bottle is made of. So a 2-liter bottle is very squishy and flimsy, but you have other types of bottles out there that are a little bit stronger. That have a little bit more structure to them, and the stronger is going to help. Just because if it's floating through the water and it hits anything, or if a boat goes over it, or any of these sorts of stuff happens, it's not going to immediately cut the bottle open and it ends up sinking. So it gives it a little bit more protection, I think.
So this would probably be a really poor bottle to work with. Tiny opening, flimsy plastic. What about a milk jug? It's like a really nice large volume. Opening in the front, though, is it too small? What are we thinking there?
Yeah. So it might be a little too small. The plastic that's also used in that is a little bit flexible. I like milk jugs because there's a lot of volume inside to work with. But the problem also with that is if you're thinking about it floating through the water, and we want to be able to track it and have good images that are coming from it, the more aerodynamic the bottle is, the better it's going to float through the water. You think about a boat, right? If you have a boat that's shaped like that little water bottle that you have there versus a boat that's shaped like the milk jug, which one do you think is going to travel through the water easier?
You think this one will go better?
Right. The good thing about having it more like that water bottle is it travels through the water a bit easier. It's going to face the right direction as it passes through because there's really one ideal way that the bottle likes to sit. And it's less likely because it's not as bulky and it's less likely to roll or catch on branches and things like that. So you should think about how you would imagine that bottle that you see in the store would behave if it were going through a river, moving around plants and things like that. What is it going to do?
Anything else that we're not asking that maybe we should be, or anything else that you think we should consider right now as we're talking about this part of the project of tracking a plastic bottle through the Sacramento River?
The only other thing you can think about is what kind of data you'd like to collect. So as we talked about, we know GPS, we know photos are both things that we're interested in. But what else are you interested in? And it'd be nice to have a full list. Sometimes those things are going to be not reasonable for many reasons, and this is what we deal with when we have projects in the lab. So we have a bunch of ideas that we want. We write a list of everything we'd love to collect. But sometimes we can't collect certain things because the sensor's too expensive, or it's not going to work in the way that we want it to, or that, it's not accurate enough for science. There's lots of these reasons why we decide not to build something versus to build something. But having that big list of everything we'd love to have is a really important thing.
Sounds like we got a discussion to figure out what kind of data we want to collect then. Shah, we appreciate your time today. We got some homework. We're going to start looking for bottles that would seem appropriate, and we're going to get their dimensions. And then the other thing, too, that we're going to do is we're going to create a list of data that we might want to try and collect, and then you're going to let us know if that data is possible to collect given the sensors that you work with. Does that sound right?
That's completely right. Yeah, I'm very excited to work with all you guys on this.
This is awesome. Let's see if we can get a selfie. Y'all ready? On three. That's me. 1, 2, 3. Awesome. Thanks, Shah.
Thanks.
See you later.